In this lesson, we're going to take a look at applications of right triangles. So what we're going to be doing is using trigonometry that we've covered, basically the sine, the cosine, and the tangent ratio, to solve problems involving quote-unquote real-world situations. So by the end of today, we want to be able to draw diagrams of situations involving right triangles. Basically, they give us a description of a situation in words, and we need to draw the right angle triangle that is going to represent that situation. And then, of course, use the trigonometry that we've learned to solve for the unknown values in these word problems that they give us. Usually it's going to be the length of the side that we're solving for. And two terms are going to be important as we go through this. These are the terms angle of elevation and angle of depression. So let's jump into our first example here. And in this example, we are going to look at the first rule of solving problems with trigonometry. It is to draw a diagram. The diagrams are key to solving these trigonometry problems. So they tell us that a kite string is 35 meters long. The string makes an angle of 50 degrees with the ground. How high is the kite? So let's draw a picture of what's going on here. We've got the ground. We've got our kite up here in the air. This is our kite, and it is attached to a kite string, which is 35 meters long. The string makes an angle of 50 degrees with the ground. We want to know how high is the kite. Well, the height of the kite is going to be this vertical distance from the ground up to the kite. Okay, that's a right angle in there. And there is our right angle triangle. So the thing that we're trying to solve is the length of this side here. I'll just label it y. And we know how to solve problems like this. We start by labeling the sides in our triangle. We know that this is going to be our hypotenuse across here. If we've got this angle of 50 degrees, this is going to be our opposite side over here. And then our adjacent side is down here. And then we look at what we are given and what we are trying to find. So we are given the hypotenuse. We are trying to find the opposite. We have an angle in here. So we look on our formula sheet and we look at which of our trig ratios contains the opposite and the hypotenuse at an angle. And that's going to be the sine ratio, because sine of an angle is opposite over hypotenuse. So let's fill in our given information here. Sine of 50 degrees is y over 35. And we know how to solve these by now. We know that we are going to multiply across here to get 35 times sine 50 degrees is equal to y. Working this out, y is going to be 26.8 meters. At the end, we should always do just a quick check to see if the value that we get makes sense in the context of our question. Does it make sense that the length of this side y is 26.8 meters? Well, yeah. If the kite string is 35 meters long, we know that's the hypotenuse, it's the longest side. So we have to get something similar in length, but shorter for our opposite side. So that's a reasonable value. Let's take a look at a second example here where we're going to encounter these two terms, angle of elevation and angle of depression. So the idea with both of these terms is that you've got an observer, that's this person right here, who is looking at something. So the red lines and the blue lines represent the line of sight from the person's eyes to some object. The red line is they are looking upwards towards something. The blue line means they're looking downwards towards a different something. And we've got this horizontal line right in the middle here. The angle of elevation is always measured upwards. So it's from that horizontal line up to the line of sight. So our observer, it's always going to be from the horizontal line up here like this, up to that line of sight. The angle of depression, on the other hand, is always measured from that horizontal down to the line of sight. So it's going to be this angle from here down. Okay. So often when we're doing questions where they refer to the angle of elevation and the angle of depression, it helps to put in this horizontal line that they're talking about to get our angle correctly. Okay, let's look at a situation here. A lighthouse sits at the top of a cliff. The top of the lighthouse is 33 meters above sea level. The angle of depression to sight a small fishing boat at sea is 24 degrees. How far from the base of the cliff is the boat? Well, let's draw a little picture here. We're going to have, I'm going to draw a cliff like this. This is the sea out here like this. We've got a little lighthouse sitting on top. And out at sea here, we've got our boat. So the top of the lighthouse is 33 meters above sea level. So if I were to say, draw in this distance, that's 33 meters from the base of the cliff up to the top of the lighthouse. There's a person or somebody up here at the top of the lighthouse. They are looking down to this boat down here. So this blue line there that I just drew is the line of sight. They talk about the angle of depression to that line of sight. So we want to draw in that horizontal line, and that horizontal line, if we look at the picture up here, always is like horizontal at that person's eye level. So if the person is up here at the top in the lighthouse, this is our horizontal line right in here, which means our angle of depression is going to be from that horizontal down 36 degrees. Oh, sorry, 24 degrees. Now, what do they want us to find? How far from the base of the cliff is the boat? So they want us to find this distance down here at the bottom from the base of the cliff to the boat. We're just going to call that x. Okay, so we've got our diagram. Let's label our sides here. So the one thing I haven't put in is that our cliff is vertical. So we'll put our right angle in here. So we know that this is going to be our hypotenuse. The angle, we don't have an angle inside of our triangle yet, which is a bit of a problem. But we know that this horizontal line up top is going to be parallel to the sea down here. So we can make a little Z pattern. And we know that this angle down here at the bottom is going to be 24 degrees as well. So we can use that 24 degrees to label our opposite side and our adjacent side down at the bottom. Then we just have to figure out what ratio. We're trying to find the adjacent. We're given the opposite. We have our angle. It's going to be the tan ratio that we use because tan is opposite over adjacent. So let's put in what we know here. Tan, our angle is 24 degrees. Our opposite side is 33. Our adjacent is the x that we are trying to find. We are going to have to cross multiply and then do division. So our first cross multiplication step gets us x tan 24 degrees. Divide both sides by tan 24. X is going to be 33 divided by tan of 24 degrees. Punching this into our calculator, we get x is going to be equal to 74.1, and our units are meters. And again, this kind of makes sense. If our cliff is 33 meters tall, that x value, it's reasonable for it to be 74.1 meters. Okay. Let's take a look at a second example here using those terms angle of elevation and angle of depression. So a video camera is mounted on the top of a 124 meter tall building. When the camera points at the bottom of a second building, the angle of depression is 36 degrees. When the camera points at the top of the same building being the other building, the angle of elevation is 47 degrees. And we're asked a couple of questions here about this situation. So let's, again, start off with our diagram here. This is going to be ground level here. We're going to have one building right here, and then we're going to have a second building over here. And our video camera is going to be right here. I'll just draw a dot here for our video camera. So the building that it's on top of is 120 meters. So 120 right there. Now, they tell us that when the camera points at the bottom of the second building, the angle of depression is 36 degrees. So if we go to our video camera and we draw in that horizontal across like this, when it looks down towards the building, okay, our angle of depression is going to be this angle right in here, and that's going to be 36 degrees. When it looks up to the top of the building, the angle of elevation from the horizontal up to that line of sight is 47 degrees. And of course, both of our buildings here are vertical to the ground. So we've got three little right angle triangles in here. So what are they asking us to find here? They're asking us first to find how far apart are the buildings. So if we want to find how far apart they are, they want us to find this distance x down here. So let's look at this first triangle that we can use here. Well, we've got the 36 degrees. So we can do the same thing we did in the last question, use that little Z pattern, get a 36 degrees down here, and then we can start labeling our sides. So across from the 30, so this is going to be our hypotenuse in here, this is going to be our opposite side, and this is going to be our adjacent side if we're working with that 36 degrees. So we're given the opposite, we're trying to find the adjacent. This looks like a job for the tan ratio because it is opposite over adjacent. The angle that we're working with is 36 degrees. Our opposite side is 120. Our adjacent side is x. We are going to cross multiply and then divide. You get 120 divided by tan 36. And then punching this into our calculator, we're going to get 165.2 meters. So that's how far apart the two buildings are. We could put a statement here. Therefore, the two buildings are 165.2 meters apart. Okay, it's a good idea in questions where they ask you two things to sort of state which answer represents which thing that they're asking us here. All right, what are we doing in part B here? We're asked to find how tall is the second building. So to do this, we're going to have to do this in two stages here. We're going to first have to figure out, we're going to have to sort of divide this building in half at this horizontal here. And we're going to have to figure out this distance here, and then add the two of them together. Our first distance we know is going to be 120 meters because that's what this height from here to here is over on the first building. So in our second building, so to find the height of like that second part up above, we're just going to call that distance y. And we're going to be working with the triangle that has the red side, the red hypotenuse up at the top here. Because if we're working with that upper triangle there, 47 degrees is our angle. The y is going to be our opposite side. Our hypotenuse is going to be over here. And our adjacent side is down below. Now, what do they give us? We know the angle. We're trying to find the opposite. The adjacent side at the bottom of that triangle is going to be same as the adjacent side in the triangle down below. Basically, it's going to be the same as x, right? So if we're looking at the distance from here to here, it's the same as the distance from here to here. That distance is going to be just x. So we have the adjacent. We're trying to find the opposite. Again, we're going to be using the tan ratio. The angle that we're working with is the 47 degrees, tan 47 degrees. The opposite side is the y that we are trying to find. The adjacent is x that we found in the first part, so 165.2. And now we just have to solve this. So we're going to cross multiply, and we're going to get y is equal to 165.2 times tan 47 degrees. Multiplying that out in our calculator, we get y is equal to 177.2. Now, that's not our final answer because we had to take that height y and we had to add it to the 120 that we had gotten from this lower part of our building. So we're going to do 177.2 plus that 120. And that's going to get us 297.15. So therefore, the building is 297.15 meters tall. So this one is doubly good to put a therefore statement at the end because we've had two parts to our calculation here. So we want to show that we recognize that the 297 is our final answer rather than the 177 that came out of the trigonometry calculation. All right, one last example here that shows a little trick that sometimes shows up in these trigonometry questions. A surveyor is measuring the width of a river using a transit, which is just like a little sighting device, kind of like a like a sight, I guess, mounted on a 1.2 meter tripod. An assistant on the other side is holding a 3 meter pole vertically. The angle of elevation to the top of the pole is 8.5 degrees. How wide is the river? So we've got a little tripod here, okay, with our transit, which is like a little, I don't know, we can think of it like a little telescope kind of thing. And this is on one side of the river, and then the river would be coming across here like this. And then on the other side, we've got this big pole here, which they tell us is 3 meters tall. So the horizontal for the line of for that transit from our surveyor would be like that, and then we're actually looking up to the top of this pole here, so that would be our line of sight. So they're telling us the angle of elevation from the horizontal up to that line of sight is 8.5 degrees. What else do they tell us? The transit is on a 1.2 meter tripod. So this height right here is 1.2 meters. That means over here, this is 1.2 meters, which means this distance up here, I'll just highlight this in green, right, isn't 3 meters, it's 3 meters minus 1.2 meters, which is 1.8 meters. So 1.8. So you can see the triangle that we have to work with up here. We've got that 8.5 degrees as our angle, the 1.8 as our opposite side. This is going to be opposite. This is adjacent, and this is hypotenuse. What we're trying to find is how wide is the river. So we want to find this distance from here to here, which is going to be the same as the distance from here to here, which is our adjacent side. So we want to find adjacent. We have the opposite. Looks like we are using the tan ratio again. Opposite over adjacent. Our angle is the 8.5 degrees that they give us. Our opposite side is the 1.8, making sure that we use the angle that's in the triangle that we're working with, not that entire 3 meters. And our adjacent side, we haven't said what that is yet. We'll just say that this is x. X is there and there. So adjacent side is x. And now we just need to solve this trig ratio. So we're going to cross multiply and then divide to get 1.8 divided by tan 8.5 degrees. That value of x is going to be 12.0. So our river is going to be 12 meters wide.